pleasure that all of you are here today. We are so lucky because this is a partner event organized by the Boosting Project in the framework of the EU Green Week. Today, you will attend to two different blocks in this webinar. The first one is focused in the boosting database that we prepared during the project live with innovations relating to water circular solutions. And also we want to explain the work behind and give you the opportunity to meet some of our innovators. After that, we also want to give you some tips or some idea of the work that we develop in parallel. In the marketplace of Water Europe is a platform that gives also the opportunity to solution innovator technology that can uptake their solution to the real market with real business opportunity. And finally, we want to give you an overview of the work that we are developing in the area of the policy and regulatory framework, main focus in end of waste criteria. So thank you very much to all of you to be here today. And I will go the word to my colleague, Rafael Casielles. He's going to explain you a little bit the boosting project, the overview, and why we are here today.
Good. Thank you. Thank you very much, Angela. I'm also sharing my screen. 1 second, I'm going to put it in presentation mode. Can you see?
Yes.
Okay, well, so yeah, thank you very much for being here today. It's a great opportunity for us to be in this EU Green Week and disseminate our boosting project and the main results. So yeah, first of all, yeah, boosting project, it's about water and circular economy, and it's about the value we can extract from wastewater, which is something we tend to see as something to get rid of. It's like a problem, but the idea is to transform this mindset into the idea that wastewater treatment plants should be seen as biorefineries. It's not only a source of water that can, for example, alleviate the very important challenge of water scarcity, which is no longer a question of southern European countries or Middle East. It's now spreading and affecting the whole Europe. But also wastewater, it's a valuable source of different materials that can be recovered. We can recover like salts, like sources for biopolymers, organic compounds, metals, cellulose. And think, for example, that phosphate is a critical raw material in Europe, and our wastewaters are full of it. So we should transform this mentality. However, there are many barriers, and the boosting project, it's about addressing these barriers. In our project, we are not producing new knowledge. What we are doing is to support innovators and researchers in order to bridge the gap between research and practice, between the innovation and exploitation. This is our aim in the boosting project. So we are addressing different barriers which are complex, interconnected, and of very different nature. There are many available techniques, technologies which are promising, but there is a lack of connection between these researchers and innovations and the market. We need to try to bridge that gap. There are also social acceptance barriers. Sometimes consumers or other industrial partners are not aware of the benefits of circular solutions. Also, we need to upskill professionals to look at the water sector with these circular lenses, let's say. There are also policy barriers. We don't have like an enabling regulatory framework to remove this type of barriers. For example, end of waste criteria. There are no harmonized criteria for the majority of circular products that can be recovered from wastewater. And finally, we need a coordination between all these actors to bridge those gaps. So in the boosting project, we are trying to address these different barriers with what we call a funnel model approach, which considers there is already a high number of research results. So we are doing in a first stage scouting, characterizing and identifying the most promising solutions and producing a database to provide them visibility. We now have a database of more than 200 WACES, which is the acronym for Water and Circular Economy Solutions, to provide them visibility. And also for those which are closer to the market, we will be feeding the Water Europe marketplace, which is an existing platform to connect technology providers and problem owners and potential adopters. But also we also narrow down from this database to select specific solutions and provide ad hoc support and assessment studies. For example, we have identified 24 case studies to conduct social and policy analysis. We selected 6 regions of opportunities from which we are producing roadmaps to address social perception barriers and specific policy recommendations. For 30 technologies, we are conducting an impact assessment so we can understand and providing a scientific solid basis which are the benefits of adopting circular solutions. And we are addressing the market barrier with a specific mentoring for 10 selected solutions where we are working with them closely also to produce adapted business models. So we are following this multifaceted approach to trying to address the different barriers. We are bringing our own projects. The Boosting Consortium has been involved in some of the most promising projects in the water sector, like Ultimate, NextGen, Hydrusa, Rich Water, Water Mining, Suwano Europe, etc. We are Biosul is the coordinator, but of course we are not alone. We have a good team of 12 partners bringing different skills and capacities for this endeavor, and yeah, we are really thankful to all of them. And yeah, this was intended to be a short presentation just to give you some insights, and my colleagues will follow up with more details about these different activities. Yeah, thank you very much for your attention.
Thank you, Rafa. Thank you. Indeed, now we will go for the next part, that is working in the based on the funnel approach that we have followed in Boosting project. We have this database of water circular economy solutions, and today the idea is that previous to give the voice and give the floor to some of them, we have Dorina Bogdani from Agenso, who is going to present the key findings of the scouting in this database and the different innovation solutions that we decided. So, Dorina?
Yes, give me a second to share my screen. Okay, so hello everyone. My name is Dorina Bogdani and I'm a project manager at Agenso. And today I will present key insights coming from the Boosting database, focusing on water circular economy solution, also known as WACES. Let me begin with the purpose of this analysis. The process started with a Boosting open call, through which a wide range of water circular solutions were collected and then compiled into a structured database. From there, we carried out a systemic analysis to better understand the characteristics and distribution of these innovations. The goal of this process was to generate meaningful insights, not just to map what exists, but to understand how these solutions can be better supported and then scaled. The overall aim is to contribute to increasing the uptake of these solutions and facilitate their transition into real-world applications. Let's now look at how this was done, starting with the database itself. The boosting database is based on an open call designed to collect innovative water circularity solutions. And to ensure broad participation, the call was widely disseminated through multiple channels, as shown on the slide, in order to reach a diverse range of stakeholders and maximize engagement. As a result, we built a strong database that forms the foundation of our analysis. Moving on to the analysis itself. Wait a minute. Yes. These slides presents the distribution of solution types identified in the boosting WACES database. Most are technology-based, followed by product and services solutions, indicating a strong focus on innovation and practical applications. However, training and financing solutions are much less represented, highlighting a gap in the support needed to scale these innovations. Overall, this distribution indicates that while innovation is largely driven by technology development, there is less emphasis on supporting mechanisms such as capacity building and financing, which are essential for scaling and implementation. Next, we look at where these solutions are applied and how mature they are. Most innovations are concentrated in wastewater treatment, with agriculture and industry also playing an important role. In terms of maturity, a large share of solutions are at high TRL levels, particularly TRL 9, indicating they are already market ready. This suggests strong potential for deployment. The next slide shows the geographic distribution of the solutions. Most contributions come from European countries, with Spain, Germany, France, and the Netherlands having the highest number of solutions. There is also participation from other European countries, showing a broader regional spread. However, we also have some solutions outside of Europe. Contributions are more limited, though, with a few entries from countries such as the United States and others. This indicates that the database is strongly Europe-focused, but with some international representation as well. To support accessibility and usability, project partners developed a dedicated mapping tool, allowing users to visualize and explore all solutions included in the database. We now move to the final part of our analysis, focusing on the key insights derived from the data. In this slide, the key trends are highlighted, the ones that we identified from the analysis. As shown in the chart, most solutions focus on advanced treatment technologies and resource recovery, which are the two dominant categories. This indicates that innovation is largely technology-driven, as said before, with a strong emphasis on improving treatment processes. At the same time, the high number of resource recovery solutions reflects a clear shift towards circularity, aiming to extract value from water-related systems. These key trends show us that the sector is moving toward more efficient and sustainable use of resources. Despite the strong innovation activity, several challenges still do persist. Many solutions remain at pilot stage with a limited large-scale deployment and also limited cooperation across sectors and regions. Barriers also adds regulatory complexity, financing constraints, and uneven regulatory frameworks continue to hinder the progress. To unlock the potential of this innovation, targeted actions are needed. Strengthening investment mechanisms, aligning policies, and promoting replication across regions are key. Supporting also entrepreneurship is also important to help bring innovative solutions to the market. Finally, collaboration between public and private actors remain essential for scaling and implementation. In summary, there is a strong database of innovative solutions, but we need to bridge the gap between development and large-scale deployment, which is still critical. With the right support and mechanisms, these solutions can deliver significant environmental and economic impact. That was my presentation. Thank you very much, and I'll be happy to take any question.
Thank you very much, Dorina. I don't know if the audience have any question, or maybe we can discuss later. Okay. So, well, now we will now move to the innovation pitch session. The idea is that all this information that Dorina gave us, you want to see today, because we have a selection of innovators and entrepreneurs, researchers who are developing practical solutions to address some of the most pressing challenges that we heard from Dorina and from Rafa. And the solution presented today cover a wide range of the topic. We have from nature-based treatment system and water reuse to digital monitoring, nutrient recovery, climate adaptation. So the idea is that together illustrate the diversity and the impact potential of circular water innovation that we have currently emerging across all Europe. Each speaker will have approximately 5-6 minutes to present their solution, focusing on the challenge that they address and the innovation itself. We are going to start without any kind of delay with our speaker, Zulema Borjas. She is Innovation Project Manager at Zurich. Zulema will present BioDAF, an innovative nature-based solution that uses biological process to improve wastewater quality for agricultural reuse, helping to increase water resilience while reducing environmental impact. Zulema, the floor is yours.
Okay, thank you very much, Angela, for the presentation. I don't know if you can see my screen.
Yeah, now you are switched to the presentation mode. Perfect.
Okay. Thank you very much for the presentation, and thank you also for the invitation. And I have to say that very nice work that you have done in boosting project. Very interesting results and information. Today I'm going to present BioDAF technology. That is an eco-efficient tertiary treatment solution for agriculture water reuse. So this is one of the solutions that Dorina mentioned before in the main type of solution that today is going to be presented. No? So first of all, I want to introduce you Zurich. For those who don't know us. We are a large company composed for more than 20 companies, very diversified. We have business in city, construction, energy, but the most important sector today, the water sector, in which we design, construct, and operate wastewater treatment plants, including water distribution systems and subaquatic works. BioDAF technology, is born due to the different situation that, as Rafael mentioned at the beginning of the webinar, we are having a very huge regulatory pressure with strict quality standards that nowadays many facilities, more specifically those wastewater treatment plants for a small cities, less than 10,000 habitant equivalents, struggle to meet in a cost-effectively way. No? So if we add the problems that we have also with the persistence pollutants that somehow leave behind with the standard treatments, I think that is for common sense to say that we are in an urgent demand for innovative reuse solutions that can operate in water stress environments. And this is what try to do BioDAF. BioDAF technology is born in the frame of LIFE project. that is coordinated by the University of Girona, and in which Sorige act as a partner for the engineered staff in the design and construction of the demo, and currently in the replication and exploitation strategy for the technology. So let's start with the description of the technology. Our key agent in the solution is, let's say, a biological catalysis, that is Daphnia. Daphnia is a tiny freshwater crustacean known for its natural filtration ability. The work that Daphnia done in our system, in combination with the biofilm that is created also inside our reactor, that I'm going to show you in the next slide, allow us to filtrate microplastic, antibiotic resistant genes, and other microorganisms. The key point here is that Daphnia operates without chemicals or any external energy input. So this allows us to have a very sustainable system from the point of view of energy consumed and also in the environmental impact. So here, a small video of the alive Daphnia in our system that it's quite curious to see, no? So more in detail, we construct in October 2023 this demo in Quart in Girona, in the northeast of Spain. We construct 2 reactors with a total capacity of 200 cubic meters per day. This system currently treats the 40% of the effluent of the Quart wastewater treatment plant. And the output, the reclaiming water, discharged in the Oniar River, or as we are going to see later, as effluent that complements with the regulation, can be used as agriculture reuse water. Here you can see more in detail our system in the wastewater treatment plant. Here we can see the pre-sedimentation tank with the different lamellas and baffles which design has been validated using CFD. These are the lamellas where the biofilm that I mentioned before is grown and perform in combination with the Daphnia in this biological filtration. As you can see, we have added organic natural cover in order to prevent the high temperatures that, as you can imagine, here in Spain, mostly in the last summers, we had. And because in the 3 years of operation, we have proved the vulnerable that can be the Daphnia with temperatures higher than 40 degrees. We operate with a hydraulic rotation time of 1.5 and 2 days. And also in the beginning of the system, we have a turbidity with set point for bypass that in the scenarios which we can have sludge inflow events, we can avoid any kind of damage for the Daphnia. No? After 3 years of operation, we can confirm these results. I think that the numbers can speak by themselves. We have achieved more than 90% of removal in microplastics, more than 80% of PFAS removal, between 70 and 100 removal for the antibiotic resistant genes, and also 98% of E. coli removal. Beyond this number, we want to promote that, and that it's a parameter difficult to put in numbers, is that we have also studied how once the BioDAF technology have been implemented in the wastewater treatment plant, we have obtained a more natural microbial community in Oniar River. We have reduced the ecological impact of the treated wastewater discharge. So this means that we are talking about a technology that it's not only sustainable by itself, but also that have a very positive impact in the ecological community. Some other details of the technologies have been put in this slide. We have very lower operating expenses compared to other conventional sand filtration systems, for example, due to, as I said before, we don't use any kind of chemical. Also, our energy consumption is minimal since we don't have aeration requirements. And the last but not the least, the space that we need for this technology. As I said before, this is a solution that it's driving to small wastewater treatment plants where the space sometimes is reduced. In this case, BioDAF needs 0.5 square meters per cubic meter of daily treatment capacity. If we compare this with other conventional nature-based systems, we are talking about 10 times less than, for example, a constructed wetland. So as conclusion, just say that this technology allows to obtain a type B quality effluent according to European standards, that it's suitable for agricultural reuse after chlorination, and that, nowadays, as I said before, we are working on our market opportunity and growth strategy. Our expectations are to have replicate the systems by the next year, at least with one replication here in Spain, to expand with other 4 operational plants in 4 years, and hopefully by less than 10 years to scale to 8 full installation across European countries, and trying to establish BioDAF as one of the leading sustainable tertiary treatment. So that's all for my part. If you have any question now, you can address me by email, number, or if you want to visit the project web, you are going to be welcome. So thank you very much.
Thank you very much, Lema. Very, very interesting. So we are going to move to another solution. In this case, supporting sustainable agriculture and water efficiency. And I'm present to give the welcome to Pelayo Fernandez, co-founder and co-CEO of WACES. Pelayo will introduce a patented technology that enhances water quality through naturally generated reactive oxygen species, helping farmers reduce water and fertilizer consumption while improving irrigation efficiency. So Pelayo, go ahead.
Thank you, Angela. Thank you very much. Okay. I wonder if you can see my screen right now.
I see moderator. You need to make the same chain that another one previous.
Yes. Okay. How about now? Can you see it full?
The same. We see the note.
Okay.
Now, perfect. Yeah. Thank you, Pelayo.
Okay, thank you. All right. So yes, let me. Good morning, everybody. First of all, and yes, I'm a co-founder of WACES, which is the company that is manufacturing this solution in Spain, actually in Almeria, and what we do is basically we change the water. In the next 6 minutes, I'm going to try to explain to you how we do this and why are many agriculture producers benefiting by this solution. So what we do, again, we are turning water into what we like to call super water. And this is a water that is more useful for agricultural processes. And what we do, actually, we change its physical structure. And that has a lot of interesting outcomes for the use of the same water. By the way, you can see here real equipment that we have installed and running, and the changes that we do to the water are focused to solve these problems, these challenges that all the farmers globally, well, not all, but many of the farmers are facing. No, the resources are less quality. The water is more. You don't get as much as before. The quality of the water is not the greatest. The regulation of the chemicals that you are using right now is very strictly changing, and now you can use less chemicals to go and do the production cycles. And at the end of the day, the profitability of the producers is at risk because they need to spend a lot more money and resources to get the same results. And that is very, very very scary, because at the end we need agriculture, and we need the agriculture to be profitable in order to exist. So that's where we can help, and we know this now after a few years of getting some results and getting some success stories around the customers that we have. So how do we work? The WACES system is a system that can be installed on an irrigation system as a bypass. So it's adapted to any irrigation system. And what it does, it is going to use only two resources. It's going to use the water that you can get out of the humidity in the air. That's one. And the other resource that we need is a little bit of electricity, but very, very, very low amount. I mean, less than any small appliance that you might have at your home. And with only that, we are going to create some molecules out of the humidity in the air. We're going to create actually hydroxyl groups, hydrogen peroxide in a very low concentration, as well as an anion of oxygen, which is O2 negative. And we're going to integrate those molecules into the irrigation water as stable microbubbles. And when you do that, the water changes, as I said before. What happens is that we're going to decrease the superficial tension of the water. And we're going to improve the dissolved oxygen content on this water. And those two changes are amazing for agriculture. They are super important. What is that? This is because we can, first, we're going to get the water easier to the plant or to the root system, and we're going to dissolve everything much better. So the water itself and the nutrients in the water or in the soil are going to get to the root system a lot easier. So you need less to do the same, which is very important. So we have been documenting a lot of big number savings in water and in fertilizers, which is, as you can imagine, a key figure when you are doing some production for agriculture. Also, we can change the quality of the water when you have the water in a reservoir or in a deposit, because normally when you keep it still, it gets some algae, it gets a high microbiology, and we can control that without any residue and in a very economical way. And also we can we are cleaning the inside of the pipes as we use the system, as we use water being treated by WACES. So these are some of the examples of why this technology is so interesting for agriculture. We have a lot of numbers, and this is some examples of less use of water, less use of fertilizers, and which is more important, zero residue, because the molecules that we are integrating into the water eventually are going to recombine, and they will be H2O again and a little bit of CO2. So we don't leave any residue behind, and we, again, help to use less and less chemicals in different processes. We have, as I said before, some success stories. We have many already, and this is one example of this proving real operations, where this Cajamar Foundation trials that were done independently by their technicians, they saw how by using WACES, well, you see the result on the pictures. I mean, the root systems are a lot more developed, and the production is increased by a very significant number of in this example. So why do we know we fit in this Europe's water agenda? Is because we don't leave any residue. We don't apply any chemical to the water. This is very, very natural. We also help to be able to use or reuse water, especially in hydroponic customers. We have many that are now being able to use the water that they are draining without getting a lot of chemicals to that water for the treatment. And that's also very, very interesting. And also what we can see is that we have our customers, they have a very fast return on their investment. That's why we have so many customers that are buying one WACES to try it out, and then they are buying a lot more in a fast time. I mean, like in less than 2 years, we have customers that they bought like 5 units, one for different places in their production facilities, because they see a return that is very, very fast. The potential of the scalability of the solution is very interesting. I mean, already you have over 350 units installed and running in different markets and for different kind of productions, from berries to flowers, from soil to hydroponics or nurseries, or even vertical farming. And at the end of the day, any pressurized irrigation system in the world should benefit from BIOS, should adopt it, because they will really benefit from it. They are so different, so many different ways of getting benefit. Testimonials, we have proof that this is already working. We have people that are buying one and then more. They're giving us some testimonials like these examples you can see here, like 13% increase in the yield, less use of fertilizers, less use of water, less nematodes, I mean, less pathogens in general. At the end, you can see that this is working already, and all we need now is to get more people to know it, because this very simple way of using this bypass and using this photocatalytic technology to treat your water, your existing water, without adding any chemicals and getting all these benefits, it makes a lot of sense. So if I ask you to, if you want to do some internal validation, or if you know somebody that might be interested on getting to know or having more information about BIOS, please don't hesitate to call me. There you have my telephone, my email, LinkedIn. You can see in YouTube, also in our channel, different success stories and different proof of that this is working already. And I will be very happy to attend anybody that needs more information. Thank you very much.
Thank you very much, Pelayo. Very, very interesting, this super water. Okay, so our next presentation address one of the growing environmental and public health challenges linked to the water management, is the antimicrobial resistance. I'm pleased to welcome Dr. Wendy Musiasari, founder and CEO of Resistomap. Wendy will present how advances environmental monitoring and data-driven biosecurity tools can help detect microbial risk, improve water safety, and strengthen resilience across water-intensive sectors. Wendy, the floor is yours.
Thank you, Angela. And hello, everyone. My name is Wendy, founder and CEO of Resistomap. I'm originally from Indonesia, and I moved to Finland 16 years ago for my PhD and postdoc at University of Helsinki on antimicrobial resistance in water ecosystem. I found that this antimicrobial resistance is invisible risk, right? Because we cannot see them. And this is why I founded Resistomap, to make this invisible risk to be visible and manageable. So antimicrobial resistance, I believe we all know, this is a very global health problem. It's actually already associated with 5 million deaths globally each year since 2024. So, and it's not only hospital problem, it's also a problem for food safety and water quality. So it's a one health problem. Water is a highway actually for antimicrobial resistance spread, because all the AMR sources from hospital, of course, from antimicrobial manufacture, agriculture, everything will end up in wastewater, right? So if we don't treat properly, then we'll end up in our water ecosystem. And this is why intervention in water is really important, because that's how we can stop the spread of antimicrobial resistance. The problem, actually, water testing, current water testing is not, or like was built mainly for chemistry or for narrow pathogen detection. So it's not for the dynamic biological threats like antimicrobial resistance. For example, culture-based E. coli is not, it's like blind to AMR, definitely. Target pathogens or target resistant genes is great, especially for early warning detection, but it's not explained where the source coming from. And also the most academic style using very powerful technology like metagenomics or sequencing, that's really, really great, but this is slow and it's not continuity, right? And there's no comparable. So the pain here, there's no standard for us to do the benchmark whether one treatment better than the others when we want to compare sites or to manage this biological risk early enough. And why now? Some of you work in water utility, AMR is must be monitored in large wastewater treatment plant, and also now in the watch list of a water framework directive in surface water and groundwater. So that's why we are here. So we transform environmental DNA from water into actionable AMR insight. So this is not just the one-off laboratory report. So we provide sampling kits and logistic after we scope what was the problem and what kind of location we're going to measure. We transfer to our laboratory in Helsinki, and we quantify the presence of antimicrobial resistant genes or antibiotic resistant genes, pathogens, also microbial source tracking using smart chip qPCR system. It's like 50 times faster than the standard qPCR. And we transform those laboratory data using our water biosecurity platform to identify source, hotspot with indexes and gene removal so that the user can control target treatment or water reuse decision, or in this case, BioDAF team, if you want to also compare and see how it's working. And there are 5 customers group that need to measure AMR, and they share the blind spot. They all need water evidence that support decision, not just the lab result. So aquaculture, agriculture, particularly in export-import quality, and like to reduce the use of antibiotic use. Public health and environmental agencies, definitely, because this is the ongoing one, particularly for One Health surveillance. As we all know, right, like we cannot work anymore in silos. And actually water is the best because water connects everything to work as a One Health surveillance. Water utility, as I mentioned, because of the coming regulation, hospitals, in this case for complement the current surveillance, because current surveillance in the hospital mainly from patients. So if we measure from wastewater, it gives them better level of AMR in the population health level. And of course, antimicrobial manufacturers make sure they not pollute the water from their wastewater treatment, from the resistance that develop there. So yeah, that's the impact of what we do at the moment. We measure more than 34,000 samples across 60 countries. So half of them are water samples. So we not only measure water samples here because, like sediment, sludge, and all of things related to water. Number of the user platform, more than 500 users, but mainly coming from researchers. The user of the water biosecurity platform is, I think, around in the 20 users because we just launched this year. So it's a very new product. And then many of this has been published in the Tier 1 scientific publication. And yes, that's all. Then if you have any later more question or regarding how to use the result, I'm happy to discuss more on this. Thank you.
Thank you very much, Wendy. It's a pleasure to see you here. And now we turn to the intersection of water management, urban design, and climate adaptation. Our next speaker is Thanos Stasinopoulos, I think, from Izmir University of Economics. Thanos will present aquapuncture, a patented solution that combines rainwater harvesting and passive cooling to create urban cooling oases and mitigate urban heat island effects. Thank you very much, Thanos. You can start.
Thank you, Angela. Can you hear me?
Sure.
All right, let me share my presentation, which is, well, I guess it's this one. Sorry for the sunglasses. I'm having a window in front of me.
Don't worry.
Do you see my
we see
PowerPoint?
The PowerPoint, yeah. And now we see the presentation mode. Perfect.
Okay. All right. This is our meeting, and thank you very much for being invited and also being present in this presentation. The title is aquapuncture, is a kind of manufacturer word to describe the idea which is an idea not about cleaning water, but about making cities better. So let me introduce the basis of this idea, starting from the physics of the environment. We all know the urban overheating problem, urban heat island, etc., which comes from the heat from the sun, mainly, and from the heat produced by us, by humans. So part of this heat is going away by convection or radiation, but it goes not far away, it goes to the nearby air. So the benefit is not exactly spectacular. On the contrary, if we use evaporation in order to get rid of heat, then we have much better results, because the heat simply is traveling far away with the help of moisture, and it is dissipated far away. So it goes away from our area. Now, based on this simple physics, we focus on evaporation as a way to make cities cooler. And not all cities, of course, can benefit from this idea. First of all, cities must suffer from overheating, like the Mediterranean. Secondly, they must be rather dry, not too humid cities, let's say nothing like Venice. But there are many dry cities in the Mediterranean, from Barcelona to Izmir and Beirut. And in those cities, we can imagine that cooling in the city can come by the evaporation, more specifically by the evapotranspiration produced by the plants. So thinking about the whole process, we can consider vegetation in a city as a kind of natural air conditioner. The problem to operate such a very effective and cheap system is that plants need water. So we come back to our topic today, how to have water. Now, I'm going to present some general idea which can be applied in many locations, which have similarities with my city, Izmir, on the Aegean Sea, where the climate is a typical Mediterranean, where sunshine is plenty, and the atmosphere, low humidity, relative humidity is low. So we can have a good potential for evaporative cooling, as you can see from this psychrometric chart. Now, strangely, there is plenty of water from the sky in Izmir, but because of the water treatment, the city is rather dry, because there is every effort to get rid of that rainwater as fast as possible to the sea, which means we don't use it at all, or we use it very little. The result is to have a water stress, although we have plenty of available water, or rather theoretically available water. So this water stress has to be removed, number one, by keeping some of the water that comes from the sky. Now I'm going to talk about Izmir conditions, but I'm sure that many of you will recognize similar conditions in your location. Now, all this idea is about creating the conditions of an oasis. Like an oasis in the desert, we can have some oasis in the urban desert. And an oasis has certain characteristics, starting from the shading. It provides shading to cut the solar radiation. It has plants that produce evaporation through the evapotranspiration of their leaves. And then in this particular idea, we add to these natural components, we add some special devices like drippers, like water walls, fountains, many devices that enhance evaporation. Now, to fuel all this use of water, we need, of course, to find the water. And instead of turning on the tap to use municipal water, we collect the water that falls around the area of the oasis. In other words, we apply rainwater harvesting. Now, this is the basic idea. And this is one generic way to apply this idea into some special structures around the city, in which we have various components. You can easily see that we have a dome, in this case, a pergola, a steel pergola, which is based on 5 gabion planters. These cubes are made of gabion baskets. In the middle, they have soil, and from the soil, you have vegetation growing and climbing on the pergola above. So this is the basic structure. Then at the bottom, there is a kind of cistern or a kind of pond where you collect the rainwater of the area. Probably there is another pond nearby, but anyway, you collect rainwater and you use that water after filtering and the necessary treatment as a kind of evaporation medium through various components, dripping and misting systems, etc., etc. So this is the basic idea in small scale, which in fact has taken a Turkish patent, as you see on the screen, for various types of applications. And when I'm talking about various types of applications, you can see here some similar, but not exactly the same ideas applied in different layout. Again, we have the gabion base, and on top some lightweight steel structure. And on top of that structure, we can imagine that we have climbers for shading and for the production of evapotranspiration. Now, this basic idea was given as a subject to our students in Izmir Economy, as it's called, the university, a few years ago, to design some cooling layout in some squares of the city. And you can see some ideas they added into their design based on this aquapuncture concept. Now, what to do with this idea? Well, basically, this is just a little pin on the city. But if you use it again and again in various locations of the drive city, then you can have some results like in aquapuncture, like in acupuncture rather. So you can have some cooling devices spread all over, cooling devices that are simple, that are efficient, and they exist and they operate in a sustainable manner. So this same idea can be applied not only in Izmir, but in many other similar places, as I said. The only thing missing, as I underline, is a pilot project. So far, aquapuncture has been an idea, but a real project is needed to evaluate the various parts of it, and also to find support not only from municipalities that can benefit by improving the conditions for their citizens, but also from companies, commercial companies, that they can be participating through the various water-related components needed in this concept, from pumps to filters to misting facilities, etc., etc. So I would be very happy to have the opportunity of further discussion with interested parties about such a pilot project.
Thank you very much.
That was the end of it.
Sorry.
And thank you.
Thank you very much, Thanos. Thank you. Okay.
Let me now stop sharing.
Great. We go. Our next innovation focus on resource recovery and the circular use of nutrients. I'm pleased to welcome Solvita. I'm not sure if I can say in the correct way your full surname. Sorry, it's Kozyukova. co-founder and CTO of P Agro Mineral. Solvita will present a solution for phosphorus recovery from water stream, transforming a major pollution challenge into a valuable resource for agriculture and land restoration, one of the main challenges that we face in boosting. So the floor is yours.
Oh, thank you for introduction and for fantastic event. Really to see all the technologies who really care for the impact and yes. So a bit introduction of our company. We are a startup, and how we were how we were born. So several years ago, we learned about. So we are serial entrepreneurs and also environmental scientists and industry. So we had worked together in different companies and now as well universities. And so we learned about the problem, specifically the regional ones. So we come from Latvia, so it's Baltics and also this East Europe. So there's too much phosphorus in effluent, what is being discharged in nature. And also, so several years ago, there was problem with fertilizers, especially in our region. So we sat around the table and decided that we need to find a solution. As well as there is already you were mentioning in previous companies also discussing that the regulatory is becoming stricter and stricter. And already now, today, those small and medium-sized wastewater treatment plants can't meet the regulatory, and there is already the next level of regulatory on the table. And till 2033, there will be influenced so many more small and medium-sized treatment companies who can't meet the regulatory about specifically talking about the phosphorus discharge in the nature. And the problems the wastewater treatment plants has that they can't really invest in renovating all the facilities. They need to operate with those limited resources, and of course, they're using different technologies, and still by using, for example, coagulants, they can't reach the levels of effluent what you can't discharge in the nature. So they pay penalties regularly, and so therefore we were sitting around the table and deciding that we need to find very the solution that is very simple for usage of such type of treatment plants, what can be added at the very end of the treatment facility, what is working only with effluent in terms of that it also comply with regulatory, etc. And so we decided that we need to search for the sorbent, and we searched for the sorbent that is beneficial as well for soil improvement, that is naturally occurring material that is locally can be sourced in our region and also in Europe. And we defined the composition and started, testing different variations, etc. And so we came to the sorbent. We call it letonide. It's a trademark. And that can really be used at the very end of the treatment plant in effluent that really absorbs phosphorus, and then we can use this sorbent with absorbed phosphorus directly on the field as soil amender. So this is a very simple way. So yes, because the objective was in that way that we can use a sorbent, dip it into the so it's in a water where it's too much phosphorus, and then use it in agriculture. And we succeeded with this composition, and also we have finalized our first small-sized pilots. What is already is out of the lab. So we work with real environment in municipal, working with municipal wastewater. So we have reached those 90% of phosphorus removal, what is really compliant with also new regulatory, and comparing the OPEX and maintenance costs, and we are for the small scale, we can see that there is savings for the customer. And yes, and also that we can reuse this recovered phosphorus in agriculture. And as well, we're very much focusing on water treatment right now because we are a startup and we really need to focus our resources. But as well, we are developing soil amender part as well. We run different tests. We have tested more than 10 different crops and variations of soils and regions, etc. So also we know about our soil amender that it has this dual benefits. So there is fast release phosphorus in it, and also the soil amender composition itself improves soil health. We also, of course, need to like the time wise, it takes quite a lot longer time because to grow something and to test, and also to test in a longer period, it really takes time. So yes, and it also gives a lot of benefits. So improves pH of the soils, and what is very important for our region because we have acidic soils. And as well, yes, so we have tested it also, those technology also in hydroponic systems and greenhouses. So yes. So yes, but we still are developing. So currently we are operating very small scale. Now you see we are the stage that we can operate. So we are starting operate with 20 cubic meters per day. So it's a very small treatment plant. And the next steps are we are scaling again because we are scaling 10 times each time. And the next step is as well. Very in line as well our go-to-market strategy. So with a pilot test in Germany and Netherlands. So yes, so we start with Germany and Netherlands, then and then we also want to reach this bigger industrial pilot up to 200 to 300 cubic meters per day. But yeah, so it takes time to scale this technology and to get all the right that its technology works very well. So about the traction, so it's a startup traction. So it's we have had as well investments and also strategic partnership with solution providers who are building this treatment equipment for treatment plants. So this is also our business model. We have agreements and license for such service providers, and as well our technology now is being validated in different industry players, Suzuka, Nihus Group, and also Kemira. And yes, and we in some time perspective, so there is discussion that we combine our technology with their technology. So yes, and the latest news is that we also were awarded this pre-accelerator AIC grant for what we are the next things that we are scaling. The next level of our treatment facility, also securing supply chain of sorbent, and then as well about how we are distributing it to farmers. So a lot of things we need to do. So yes. So thank you very much. This is very shortly, but if you want to know more or connect with us, as we are also very open to different projects, different pilots and validations. So we are very open. So yes, thank you very much.
Thank you very much, Solvita. Thank you. Continue with resource recovery. Our next speaker is Jan van den Broek, Director of Business Innovation at NII WACES. Jan will present advances ammonia recovery technologies that enable wastewater treatment facilities to recover nutrients as fertilizers while significantly reduce carbon emission compared to conventional treatment approach. Jan, please go ahead.
Thank you, Angela. Can you see my screen?
Yes, we can.
Okay, fine. Thank you for the kind introduction and for being able to present my story. My name is Jan van den Broek. I'm one of the founders of the company. And the topic is about the recovery of ammonia as a fertilizer. So it fits well, I think, in the Boost-In program. One thing is, sorry, that was too fast. Yes, next slide. We are part of Sur Industries. I think previous speaker also mentioned that. And Sur Industries is all about closing the water loop, restoring the water loop. And WACES is part of the group since 2022. And the company is focused on reuse and recovering specifically of nitrogen. And I can tell for those of you who are still in an early phase, it took many years to develop something into what is now gradually accepted as common technology in wastewater treatment. But it takes time and endurance. So about our technologies, the main technology that we worked on and have most references on is BioFlex. It's innovative stripping technology where we use an acid to bind the ammonia. But we're also working on innovations where we have demo plants. One is we call that BioLoop, where we use a bipolar system with electrodialysis to recover the acid and reuse it again and recover ammonia as ammonia water that can be upgraded to 25% ammonia water. And we also have BioNix, where we bind the ammonia to CO2 that can be upgraded to an ammonium bicarbonate solution. So these units are actually built as plug-and-play systems used for polluting substrates like sludge digestate or digestate from industrial and agricultural digesters. And typically we can get 85% stripping efficiency without an alkaline agent, although it is possible to even go higher, and that is actually what in most cases we do. So we don't work with an alkaline agent, which is also one of the USPs of the system. And it's very robust in terms of pollution. We have high tolerance against pollution. No pre-filtration is needed, and the systems are completely automated. So with a very easy start-stop system. Now, if you look at how we recover ammonia, if we use the acid, you can use different acids like sulfuric acid, which is most common because it's cheap. Then you can recover it as a liquid, ammonium sulfate liquid or ammonium nitrate if you use nitric acid. And the blend of the two, ammonium sulfate, saltpeter, is also interesting. But we also have one installation where we use citric acid and we bind the ammonia as ammonium citrate. So I already mentioned that if you use CO2, you have ammonium bicarbonate solution, and if you use a bipolar system, then we can go to ammonia water. So something about the presence of the installations. We are Dutch-based, and so most references we have are in the Netherlands and in the western part of Germany, but we're also very active in Italy, UK, in the Nordic countries. And also since we joined the group in 2022 in the US, we also have 2 installations in South Africa. These are some examples I'd like to share. This is an installation we are currently building for the municipality in Oslo, so it's really a big one. And here we built 4 units of 4 times BioFlex 20, which is roughly 4 times 20 cubic meters per hour. And it's around a sludge digester where sludges are being digested, but also nitrogen is converted into ammonia. We strip that out, and the contents go back to the wastewater treatment plant to actually relieve the wastewater treatment plant. The system here is combined with thermal hydrolysis system from Cambi. And in this case, the thermal hydrolysis system is after the decanter. And I don't know if you can see my pointer, but the effluent is sent back to the digester to increase the biodegradability and get more biogas out, but also to have less sludge, which is one of the main business drivers. Another idea of a project that we are doing, in this case, the customer is treating industrial sludges. And here we had to meet effluent limits because afterwards the water is treated with a wastewater treatment plant, but they were very strict on ammonia loads and solids. So in this case, we have a decanter, then we have a stripper, then we have a DAF unit. The solids are sent back to the digester, and the effluent is then treated in the wastewater system. In this case, what we hope to demonstrate is that we use less chemicals and less flocculants in the DAF system. And that is why the ammonia stripper is before the DAF system, but the system is only in operation since April, so we have not really real data yet. But what the thing is, with ammonia stripping, you also reduce the alkalinity. So yeah, you should use less chemicals. Then something about the business drivers. So I know this is about circularity and sustainability, but it's not the top priority of our customers. Actually, why they choose ammonia stripping over biological alternatives is because it's easy to control. It's flexible, and you can start up from standstill to full operational plant in let's say 15 to 60 minutes, depending on the size of the installation. And it's robust and reliable. And in terms of safety, you don't have any risk of Legionella, which is a big topic in the Netherlands. So what we see in the municipality, but it differs from country to country, is that laughing gas emissions is a topic. What you don't have with stripping technologies is you for sure don't have any laughing gas emissions. And we recover nitrogen as a fertilizer, and it makes sense. So in those countries and for those customers who look at that, we have an opportunity to mention that. But then it always comes down to OPEX and CAPEX. You always have to compete with the existing technology, and this is the most complicating one. And there are various items you have to look at. So it's alkaline agent, it's the ammonia content. Is it possible to use waste heat, or do we need a maximum heat recovery? Benefit is that you don't need any extra carbon source. You have less or no extra sludge production, compact and modular. So that's the most complicated exercise. And then the last one, which is actually the cherry on the pie, is the production of the renewable and fertilizer. Nobody is really at the moment really interested in it. It also has a relatively low value. So it is the least of the business value, but it will become more and more important in the future. That's what we believe. So some pictures to end my presentation with. This is an installation where we have 4 lines in series. So it is scalable, and it's also very compact. That's also one of the benefits. In case you have any questions, please respond to us or to me directly. Thank you.
Thank you, Jan. Very interested, and thanks to be here today. We go for the next presentation, addresses another major challenge for aquatic ecosystem and water quality, the microplastic pollution. It's a pleasure to welcome Dr. Catherine Sushan, founder and CEO of WACES 3.0. Catherine will present an innovative circular approach that combines microplastic detection, removal, and reuse, helping industry and utilities reduce pollution while advancing circular economy principles. Catherine, welcome and thank you very much.
Thank you very much, Angela, for the kind introduction. Hello and welcome to this short lunch talk about microplastics. It's a pleasure to present WACES 3.0. I'm an inventor, founder, and CEO, and together with my teams, we develop and scale solutions for waters without microplastic. When we talk about microplastics, the question of what is the current state of the art? And the current state of the art is that industries do not remove microplastics at the moment, and they release tons of microplastics per facility per year via manufacturing, production, recycling, wastewater release, pellet loss into the waterways and finally into the environment. And on the municipal level, it's the same issue. So we have wastewater treatment plants. They are able to remove a small amount of microplastics, but per facility per year, about 500 kilograms per wastewater treatment plant per year is directly released microplastics into the waterways. And if we only focus on Germany, where WACES 3.0 is based, we talk about 10,000 wastewater treatment plants. And then it becomes an issue to remove microplastics because 10,000 times 500 kilograms means an impact. But at the moment, there are no plans to retrofit the systems. There are no plans to have a forced cleaning stage, including microplastics removal. But we all know microplastics affect our health, biodiversity, and all the issues around us. And in the end, we eat, drink, and breathe microplastics, so we have to remove them. And removing means the big question, where is the right point and where's the right time? And one thing must be clear. If microplastics are released into the environment, it's gone forever in terms of 350 years and slow degradation. In the ocean, we have 1 microplastic per liter. In our rivers, slightly more, 10 to 20 to 100 microplastic particles per liter. But when it comes to municipal and industrial wastewater, the amounts are quite higher. And the impact for the removal is way much higher as well. How do we know that? First, we invented the rapid microplastic analysis. It's a standard. The EU is looking for a standard. We have the standard. It's validated and an efficient tool to quickly and cost reduced doing a microplastic analysis in all waters you want to do the analysis. It's a question of which method and what should be the result in terms of fluorescent markers, which we invented at WACES 3.0. We have the tool in hand to combine the staining process with a very fast analytical tool with the microscope and get the information about the hotspots. And you can see on the right pictures where the hotspots are directly without knowledge, deeper knowledge about how microplastic analysis was performed. In industries, you see glowing particles. And if I say to you, every glowing particle is microplastic, then you see, oh, in industry, there are lots of particles in our wastewater. Moving to the wastewater treatment plants, there are less particles. To rivers and tap water, they're more or less nothing or very, very low concentrations. So with the knowledge that in industries and wastewater treatment plants, it comes to the solution pathway. And the solution pathway in terms of WACES 3.0 means that we not only focus on the removal, so the single route, like the filtration, they only focus on single routes. We directly incorporate the reuse aspects, the reuse of the water, so the cleaned water, and the reuse of the agglomerates coming out of the process. Agglomerates, what's behind that? So the big question is, how do we perform the microplastic removal and what does agglomerates mean? We have invented a hybrid silica gel mixture, which is able to clump particles together. This is the first very important step. We only need a very low barrier in technology application, so it's not rocket science. It's a simple reactor where we steer the wastewater. The particles are localized in the vortex. We add the hybrid silica gel mixture in the amount which is needed, no overdosing. We know about the concentration before, we detect the concentration afterwards. Within minutes, we see this clump process. So the particles are clumping together, floating on the surface. We separate them very easily. And what it comes out of the process are the agglomerates ready for reuse and the microplastic-free water ready for reuse. So in terms of circularity, we have two streams. We remove the microplastics, we increase the sustainable process design, we reduce the costs, and in the end, we have clean water which can be directly released into the environment. We have run several feasibility studies, more than 20 now. Here is one example from an industrial operation, one plant, packaging industry from 2025, already published and open accessible for everyone in this call and to all others outside this call as well. What we have in this operation, we have a 99% microplastic removal, showing that from the analytical perspective. We have the COD reduction, we have the water reuse quality. And in terms of agglomerates, we know now from the agglomerate qualification process that the agglomerates can be reused as building materials. So a full circle for water reuse and agglomerate reuse. The same for a municipal wastewater treatment plant. Municipal wastewater treatment plant in Mykonos has only 2 treatment stages in the traditional line. And here we set microplastic removal, a TSS removal, COD reduction, and finally they have the chance to match the EU limits according to the Water Frame Directive. Because here we have the direct connection to the ocean because the cleaned water is directly discharged to the Aegean Sea. So what is the market? The market is emerging, but what we all have to keep in mind is that microplastics at the political level comes with the analytics. So what we present now is the standard analytical method to monitor microplastics in wastewater streams, to evaluate the hotspots and get the first step to start the removal. Removal takes place in industries. Here we go with feasibility studies and licensing models in the municipal wastewater treatment plants. We directly cooperate with the force cleaning stage evaluations and plannings. And in terms of circular materials, it's very interesting to see how important our agglomerates are for the construction and for other industries. This is the team. We have more than 20 years of experience. It's a young team, but we were in this field of microplastics for a very, very long time now. We are active on several levels, from the EU Mission Ocean on the one hand, in the World Economic Forum and in the environmental program of the United Nations. And that is an overview how microplastic can be solved in the future when you know about the hotspots and start with meaningful solutions. Thanks a lot for the kind attention, and reach out for questions or starting your feasibility. Thanks.
Thank you very much, Katrin. Very, very interesting. I think that for sure we will connect sometime.
Thanks a lot.
Okay, so last but not least, I'm pleased to welcome Hasse Storbakken, CEO and co-founder of Aqualarm. Hasse will present a digital solution that uses hydroinformatics and advanced analytics to improve drinking water management, enhance water safety, and reduce energy and chemical consumption across water distribution systems. Hasse, thanks for waiting, and the floor is yours.
Thank you. Thank you for having me and for the introduction. So I'm Hasse Storbakken, founder and CEO of Aqualarm, and I'll now show you what we built and why utilities are starting to put it in the ground and what this will mean for the environment. The largest process and distribution industry, water, in Europe does not have a clear picture of what is happening in their pipelines, and this is a visibility problem. To optimize this industry, you need continuous data, not weekly with samples, etc. This lack of visibility drives monetary and environmental costs and creates significant risk to public health. And we're about to solve this. Today we have a team of 12 across Norway, the UK, and Denmark. What I want to show next is not a sensor, it's not a dashboard, it's an operational layer that for the first time tells the utilities what's happening inside its own network and understand why it's happening. We use microbials, sensing microbials, as an important part of our data and water science. The same I would do if I designed a water treatment plant or a service reservoir. It strengthens the data correlations and world models that we build. Here's a change we're trying to make. On the left is how a utility operates today. On the right is how a utility operates with Aqua Insights in the network. The difference isn't a faster lab result. The difference is that the decisions move from after the contamination happened to before it. So from reactive to proactive. And the next 3 slides will show you how. 3 layers in this product. First, it's a microbial sensor. It reads tryptophan-like fluorescence directly in the pipe, twice a second with no reagents, no consumables. Tryptophan is a well-validated indicator of microbial water quality and correlates with total coliforms and E. coli. Sensing costs in this way are roughly 5 to 10 times cheaper than flow cytometrics. The second is the programmable autosampler. When the sensor sees something interesting and the sampler grabs it, you can get hold of water forensics there and then, which is very demanding. The third is the platform. We fuse the microbial signal with the utilities, existing SCADA, GIS, and meteorological feeds, and a causal AI engine maps out cause and effects. The operators sees not just something happened, but this is why, and this is what we recommend. We have a patent pending on this integration. We have a paying pilot live in a major UK utility, 9 sensors across multiple assets in a regional supply zone. In the water since April 25. So let me show you one event from that deployment. Over a 40-hour period, the utility reduced chlorine dosage upstream. 24 to 48 hours later, exactly the lag you predict from the hydraulic residence time of the network, our sensor voltage at the downstream service reservoir rose roughly 4-fold. The response was proportional. It persisted. It returned to baseline as the system recovered. This was one of 5 hypotheses that our Water Science Advisory Board tested in a recent independent analysis. All 5 came back consistent with detectable causal mechanisms: chlorination, water age, trunk flow, conductivity, and catchment hydrology. So this means that the logic, the mix of these technologies is set at TRL 6 to 7. In the water with paying customers today. The signal is real, the mechanisms is real. The work now is making it real time at scale. What does it actually change for the people running these utilities? Well, some of our customers pay very high penalties for not having control, and we can help on them. Financially, there's also a lack of visibility. When you do a complex operation, you normally overuse resources to keep customers safe. We expect a 5 to 10% reduction in operational expenditure at the typical works. From an environmental standpoint, fewer reactive chemical interventions, less overtreatment, less chlorine breakdown chemicals into nature, less premature replacement of expensive infrastructure, simpler to reuse water, and also lower pressure in pipes, which is a poor security arrangement, securing that leakages go outwards and not inwards. But it costs a lot to drive with electricity, and it's a major cause of CO2 emissions. 3 things on the market approach. First, we started in the UK 25, and well, the reason is simple. I mentioned it. It is about the heavy penalties that they have there. Second, how we will scale. From 27, we move to channel partner distribution. Our collaboration with companies like Sweco and Covi are examples of this. Third, how we sell. CapEx-free SaaS, so software. We sell basically the information, 2 tiers. Visibility, which is cheap, only telling something's happening. We do not know what, why. And insights that requires a lot more data, but pattern recognition is useful in this case to bring real deep knowledge on exactly what's happening and bringing up proposed actions. So where are we heading? We're moving from TRL 6 towards 9 by 28. Every new deployment adds a new library of reusable causal asset models. So a water treatment plant model can be reused, a storage facility model can be reused, but adopted for future reuse settings. Beyond drinking water utilities, we're already seeing pull from industrial process water reuse, particularly in Italy, and from dual-use critical infrastructure operators. On the capital side, we have applied for soft funding from different providers such as ESC, Accelerator, OFOT, World Economic Forum, and we target a Series A in 28. We do have to have partners to make this spread around the world. So channel partners and collaborational partners and partners with products that align with us but not doing exactly the same makes it more attractive for the customer to buy. We do need to meet with those water utilities that are the most forward-leaning, and advice on to find them and get them into motion is critical for us. And we need investors that can basically help with this, but also with, of course, money. Thank you. Thank you for holding out throughout this prolonged meeting.
Thank you very much, Hasse, and thank you very much to all our innovators for sharing this inspiring solution. I know that we are running behind the schedule, but I think the quality of the presentation fully justifies give them a little extra time. And what we have seen today is that Europe has not shortage of innovative solutions. The challenge now is ensuring that this innovation reach the right stakeholder and find pathway to implementation and scale. And this is where the Water Europe marketplace plays an important role. Through boosting, we have contributed to enriching the platform with circular water innovation and supporting new functionality, including a matchmaking tool that helps connect solution provider with potential user and pattern fundator. So to tell us more about the platform and its potential to accelerate innovation uptake across Europe, I am pleased to introduce Andrea Rubini, Director of Operation at Water Europe, and he can explain us better the Water Europe marketplace.
Thank you so much, Angela. Thanks, to all the speakers. Really, indeed, a lot of innovations in Europe. And then you're right. We need to outreach the market, which seems to me to be easy, but it is not, because there are a lot of enabling conditions that are required for innovative solutions to be deployed in the real life environment. And to start sharing my screen, and there is the reason, one of the reasons for which we have been supporting since the very beginning the development of a marketplace. Let me go soon into what is the marketplace and for whom the marketplace is made for. So let's give them a bit of background. The marketplace started its adventure or its travel in 2020. So it's 6 years ago. Even before the COVID era, and it was a first objective of one research and innovation project of Horizon 2020. It was in the Next Gen project, and since 2020, I've been working on developing this platform, this digital platform, which aims was, to give an opportunity to innovators, to solution providers that might or might have not been, participating to projects, in research innovation project, to upload, to make visible their solution. Now, in a nutshell, the marketplace is a digital platform that is for market-ready products, that both technology and services. So it's not only about let's say physical things or physical assets. When you say market-ready products, market-ready innovation for the water and water-related sectors, we might also include services. Including also skills development activities. And this, in order to support circularity and resilience of the European water environment and domain. It is important now also to highlight the matter that this marketplace is also means to support innovation, not only for a matter of visibility, but really to increase their capacity to outreach the users or the problem owners for that might be waiting for finding solutions to the increasing water challenges. So in the end, this is a digital platform. I don't dare to say that it's the Amazon water marketplace, but it's a place where it's a B2B digital platform, so it's business to business, in which problem owners and solution provider can upload either the problem or the solution. So at the end, who will be the users? Who are the users of the marketplace? Problem owners, I would say, could be utilities, industries, farmers. Whoever has a problem for which they want to expose and find a solution. And then, of course, it is for the solution providers, companies, research institutes, that have technology providers at large, small medium enterprises that have one or more ready to market. This is important, ready to market solution to upload and make visible. And then, of course, there's also a place where investors can step in and assessing also opportunities for investment that could be supportive in terms of expanding in the market of products and services. Now, the marketplace still may receive support from EU-funded projects. Of course, it's Boostin, the sister project of Boostin CIRSO, and also the European partnership on water for all. This is also important because apart from the matter that the marketplace still needs support in terms of refining its performance and its capacities. At the same time, the matter that we can also add support of such a large partnership like Water for All increases also the opportunity for utilities, industries, companies, technology providers, to be visible to quite a large audience. Consider Water for All, it is made of 33 countries with more than around 90 partners, and it is really visible, in Europe and beyond Europe. Now, this is how it appears, I mean, the Water Europe marketplace. Some key figures of the WAMP, of the Water Europe marketplace, is 500 stakeholders, 26 products ready to market, 71 technologies, and on the other hand, the marketplace is also a place where the EU research and innovation projects can drop, I mean, as a repository, the demos and pilots. This makes sense in the marketplace because anyhow, this is also an opportunity for giving visibility to results of research and innovation projects that might not be ready to the market, to upgrade, I mean, to the market uptake and be ready, I mean, for being commercialized. As I said, I mean, the WAMP development has been supported by, and has been supported by the boosting projects, by the CIRSO project and Water for All. At the same time, as you know, Water Europe organizes at least once in a year the events called Water Market Europe, and in each event, in each Water Market Europe, the Water Europe marketplace, it is well advertised and disseminated. Now, in terms of products, in a product listing page, it showcases market-ready innovation. It connects, it shares, I mean, and this is for elevating the solutions of the technology providers, I mean, to the wide public. What is important, there are, I mean, a number of tips and tricks, I mean, for the marketplace. Of course, I mean, whoever, I mean, is welcome to upload the products. A registration is necessary. So how it works? A technology provider can register and create an account. Can fill, I mean, the profile page and start uploading and matchmaking the products. Consider that registration and uploading is free of charge. The network can be expanded as much as you wish. And then, I mean, this is the main aims is showcasing the product across Europe and beyond Europe. What is important is that apart from being free of charge, the products that are uploaded today will be visible after a bit of time because there will be, of course, I mean, a check, I mean, a quality check of the uploaded solutions, but they will remain visible for 1 year only, because after 1 year, the owner of the solution will be informed that if there is no update of the solution or there's no change or whatever, I mean, could modify, either the owner has to confirm that the solution remains as it is, or it is requested to update the solution. This is in order to avoid that the marketplace becomes, I mean, a repository of old technologies, old innovation that, as you know, I mean, innovation runs as much as, I mean, as the wind could do. So this is that's all. You can have access, I mean, to the marketplace also through this QR code. As I say, I mean, companies, product owners, solution providers are very much welcome to upload the products. It is for free. Take this opportunity. And once again, I would like to thank the Boosting Project for the support given so far, and hoping that the marketplace will be an important instrument for development in Europe and beyond Europe for the water domain. Thank you so much.
Thank you very much, Andrea. And also this gives me the opportunity to say that in autumn, we will have another webinar giving possibility to the innovator as today, but also we want to introduce all of you this new matchmaking tool of boosting. So it will be another possibility to know more in depth the marketplace functionality and the opportunity to bring to all of you. And well, we approach the final presentation of today's webinar. I would like to highlight another important aspect for scaling circular water innovation, what is the regulatory framework that enables recovery resources to become value products. To give light on this topic, I'm pleased to introduce Christian Remy, Senior Research at KWB. Christian will present the role of the end-of-waste criteria and regulatory aspect in enabled circular water solution and the work that they do in this topic within Boosting Project. Christian.
Thank you, Angela. Thank you very much. Welcome everybody. I'm promising to wrap it up in a few minutes only, but I will tell you something about a regulatory barrier actually that is hindering many actors in the field of circular water technologies to move on because they need end of waste. So what's it about? End of waste is a legal status that you need to move from a waste regulation to a product regulation, and everything that you recover from wastewater in any terms has a waste label on it. So if you want to recover it, if you want to market it, if you want to sell it, you need to move from the waste to the product regime. And for this, you need this end of waste status, which is kind of a gatekeeper between waste and product. So how to reach end of waste? Well, you have to fulfill specific end of waste criteria that are defined in their type, but not specifically. And that's the problem, that we lack a lot of harmonized of these end of waste criteria for all these new products that come out of the water sector. Talking about cellulose, talking about bioplastics, metal salts, whatever you can recover from wastewater, they don't have European harmonized end of waste criteria. So what to do then? You need to make it your own, basically. So many sea actors struggle to define these end of waste criteria that are fulfilling the general types and how to define them, but they need this end of waste status. So it's really a major barrier for circular water products. And also the authorities which need to grant end of waste, they lack know-how and guidance of how to do this. So what we learned is, okay, end of waste is really a barrier, a problem. So what can we do about it? And in the Boosting project, we are working towards more harmonization of these end of waste criteria on the European level. And we started actually with some interviews. So we checked with stakeholders, we checked with experts, we made workshops and trying to elaborate where we are at the moment and what is really the problem and how are ways to move forward. We even had public events on an IWA conference last year, very popular, and also some webinars on this topic. So what we made so far is we explored the state of play and wrote it down into a report. And here's the link, so you can access it afterwards if you like. And we exchanged the experiences that all of us had, so the stakeholders that are involved with end of waste criteria, and checked ways forward. And also we try to promote, of course, the harmonization of end of waste criteria. This brings me to my last slide actually already. So what are our key learnings about this, and how can we move on from here? So what we learned very quickly was that European harmonization of these criteria needs a very intense stakeholder process. So it's a really multi-year process, which is moderated by the Joint Research Commission. And this is basically a defined framework where this harmonization takes place. So if you really want to have harmonized European criteria, you need to follow this process with JRC. And we also learned that water products at the moment are not at the highest priority level in this process of developing criteria. So what we also think is that if we want to move forward with circular products in the water sector, we need to have them on a higher priority level towards defining end of waste status. However, there's still some good news. There are different routes available already today to get this end of waste. So it's not only your own work, you can also try to develop national criteria on a more national level. You can develop your own self-assessment, which needs then to be challenged, but you can move forward by yourself somehow. So there are different routes available, and we need to connect and to exchange and learn from others in this world to overcome the barrier of this end of waste criteria. So our next steps would be to really propose some concrete end of waste criteria for specific products and try to propose them for future harmonization. This will be done in the second half of this year. But we're also aiming about setting up a network, a European network on this challenge on end of waste in the water sector, really, because we saw a lot of sense in connecting and talking to each other and learning from each other. And many companies involved in this were very interested in learning how others do it and not being on your own in the struggle of achieving end of waste status for your new products. So my last invitation would be to join this network actually and express your interest and bring your end of waste case to the table if you have one, or if you are struggling with end of waste. here's a link, here's a QR code, and we're still setting up this network. So everybody is free and welcome to join it and to learn more about how to overcome this very critical challenge to circular economy in the water sector. And that's it from my side to be in time. Thank you.
Great, Christian, as always. Thank you very much. And this brings us to the end of today's Boosting Innovation session. I would like to thank all our speakers for their excellent contribution, all the innovators who shared their solutions, their ideas, and all of you who joined us today from across Europe and beyond. We have seen that circular water innovation is already delivering concrete solutions for nature, climate resilience, and resource efficiency. The challenge now is to help this innovation reach wider markets and achieve greater impact. We hope today's session has provided new ideas, new connections, new opportunities. We will share all the presentation material from today's webinar with all registered participants in the coming days. So please keep an eye in your inbox also for new webinars that we want to continue during autumn. Thank you. Thank you for being part of the EU Green Week partner event and for supporting the transition toward a more circular and water smart Europe. Have a wonderful day from all Boosting team, and thank you very much again. Bye.
Thank you. Bye-bye.
Thank you very much.
Thank you. Goodbye.
Bye.